Okay, let's get started on the base slider. On this one, I'm going to do the top view, which has the advantage if you're coming from a 2D background that we can generate most of this geometry fairly quickly, and then use the contours and regions to build up the shapes. Most of the time, I would, as I mentioned in the overview, would do this in geometry first, and then have separate items to work with. So let's fly this out of the way. Get the SolidWorks going. Okay, so file, new part. We're not ready just yet to start our file management, but we will be here pretty quick. And so for this, to visualize how this is going in the assembly, I'll start on the top plane. And we can go with a rectangle. And I'll just put the origin on the left side. So right click, select the origin, hold down the control button, select the line, go to the midpoint, and our overall dimensions then get into the drawing. Oh, I guess I missed, so smart dimension. And I am in inches, so I forgot to pick my metric. So let's go ahead and put the overalls on. So 280 by 60. We got our overall dimensions. Oh yeah, I'm in inches, so I just made that 280 inches by 60 inches. So let's go back and correct that by doing 280 millimeters. And let it update by 60 millimeters. Okay, so now when I go into the millimeters, grams, and seconds, I know it's going to kick me out of the sketch. We can right click, edit sketch. It will zoom up for me. Dimensions are out a little ways, not too bad. Sometimes they get thrown pretty far. And then most of the time I'd do a center line, infinite length. In this case would be horizontal. Here we can just go from the origin or midpoint to midpoint. Go back into the line. Sometimes it's easier just to go in back into the command rather than it is to try to back out of the property manager. So missed the horizontal, so we'll put that in place. And this dimension, so this is one of those places where we can use the diametral or the radial or the half dimension and the full dimension. So as long as I stay between the object and the center line, I will have the full, and if I go to the other side, then we'll have the diametral. So place that, we have the 20, and it should automatically be symmetrical. So our mirror can go a couple of ways. If I select and control select the center line, we go to mirror entities, and it will automatically do the mirror. Click on the Control Z to back up one. Make sure I don't have anything selected this time. So if you just go to mirror entities or right click and let's see, it's going to be under sketch tools and mirror entities. That will take you into selecting the entities to mirror and to mirror about. So even if for some reason you didn't want to copy, and which gets rid of the original, stay with the copy and leave the copy on. Otherwise, the mirror doesn't really work all that well. Basically leaves your sketch under defined. And if I have to go through all of that, I might as well pick up the drawing again. So 10 on the diameter. It is on center line, and 20 in from the edge. Okay, and then for the hole locations, we'll introduce the hole wizard. So I'm going to draw 2 points for the 5mm hole locations. Make those horizontal. Since they are still selected, I can tell they're selected because they're in the magenta. Again, yours might be blue or grayish, depending on what you set. Control select the center line, go to mirror, and now we have those geometries established. So 5mm off the edge. And then we're 160 between the points. And 115 from the edge. And because these are centered on the 5 and symmetrical, then that's everything we need. All right, so if this was a true layout sketch, then I would leave this. I would probably rename it and leave this, but we can go ahead and start building up our geometry. There's not too much in the way of complexity here. So go into the sketch, tell it to extrude. If I want to go with contours first, and let's see, our overall height is 44. But the first stage is 24, so let's start with it. And we'll pick that geometry. And then I want to expand out the feature, go into the sketch, extrude again, and I'm looking for the regions, and depending on what it finds, come back over here and make sure that I get either side of the center line. And 44 for the overall. As long as these are merged, a positive into a positive is no net gain. Oh, and it did add the pin, but the drawing is showing it as going through. So I got a couple options. Is I could go back and make the cut. So let's do that first, and then we'll look at the other option in our selection. So if I go into the sketch, and just like we did the boss extrudes, we'll do an extruded cut. And when I select the contour, probably going to be easier to rotate this around and zoom up a little bit. And if I reverse the direction and tell it to go through all, that will find the end geometry. So that's one possible solution. And we can double check that it goes through by rotating over and looking down through those. Then the other solution, let's go ahead and suppress. The other solution is just to edit the first sketch that had the contour. Oh, take that back, edit the first feature. And in our selection set down here, we have sketch contour 1. And if I add that to the mix, that will also make it so the hole exists before we do the other one. All right, so you can kind of see it there with rollback. So if you happen to see the little hand grab that bar, then that bar is the rollback bar. It's going to bring in those, going back through the history of your part. So let's show the sketch. And we'll look at this from the top, so Control 5. Because these are on the same plane, shouldn't have to do too much with them. And we have 5 millimeter holes, 10 millimeters deep. So this is where we can start to use the hole wizard. So if I just drew the 5 millimeter circles, I could extrude them 10 deep, but we'd also want to utilize some of like the drill geometry, or if this is a drill and ream type situation where we want this to be close, because um, usually the pins are going to be a purchase part, so those are whatever size that the tolerance of the manufacturer provides. So that becomes a shaft basis for our tolerancing. So if I wanted to press on this side, it would be really close to the same size and a minus dimension, and then on the part that's sliding over, it would be same size with a plus dimension. So just kind of thinking through those processes before we get to them. All right, so antimetric, if I leave it as a dowel hole, when I get to the drawing, it's going to show as a dowel pin hole, but that helps a little bit with the tolerance, but it can also make the drawing a little more confusing, so you have to kind of decide what the value is there. So when I tell this to go 10 millimeters, the nice thing about the hole wizard is it's going to ask me, do I want that to be to the shoulder of the drill or the full depth? So if it adds the tip into the depth, we can build that in. If this is going to be a reamed hole, so we have 5 millimeters, which is 197 in inches, then I might want to do a 197, 196 to 197 and make that a press fit. So that's one possible, but that's where the callouts and the additional tolerances come into the mix. All right, so going back into the positions, it's the hole wizard is automatically going to go into point, and wherever you put a point, there's going to be a hole. So we'd go point, 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 and point. I'm just looking for those to be coincident with the existing and generate the sketch. And now I can hide that sketch. And when we go to save, we'll let this catch up. Figure out where my assignments are. Create a new folder for assignment 3. And this is the slider base. All right, so naming convention, however you want, since they missed a few of the names, we'll pick those up as we encounter them. So let's go back to the drawing. Zoom that out a little bit. So again, next piece, we have the 2 circles, so we can do the contour region here again. And then we will also illustrate that as a revolve. So new part. And do I have the part millimeter? Part metric. All right, so I'm going to jump back into my templates and use the part metric. So if you've created those, by all means use the ones that are going to save you that step of changing from inch, pounds, and seconds to millimeters, grams, and seconds. All right, so again on the top plane, just kind of visualizing the way I want this to come into the assembly, into the drawing. We'll draw the first one, and this would be a good time to turn on the numeric input. So the next circle is 22, and then the last circle is 10. All right, and then the one that I started with is 80. Okay, so it's going to go back to linear, not crazy about the linear, so let's get out of the dimension, go back into select, right click on that. And then we have radial, dimetral, and the linear. So that looks a little bit better. So when you right click on any of these dimensions, if it's available for that, you're going to see the display as radius, diameter, linear, and then the auto, which usually we're not doing that close. So if I go back to the dimension, click on the dimension, go to the property manager, and then to leaders, that's where we're going to see the same radius, diameter, linear. And then also if it's a linear dimension with the circles, we'll see the max min conditions in that that group as well. So just be aware and have an idea of where to find those. All right, last circle then is 8 millimeters. And I want to zoom up on that so I can pick the origin, control, pick the center of the circle and make it horizontal. And then between the two is 32. And our geometry updates, so we'll feature extrude. And the first edge is 5. And we'll go with, it doesn't really matter. Let's just go with the 1 and we'll use this as an illustration. I could have picked the contour and the contour. If I pick the region, then that's excluded. That's excluded. It's just one of the processes that we go through using those geometries. So if I show the sketch, and then we go back and do the extrude boss base, oh, the sketch did not get picked or pre-selected, so since I can see it, we will highlight, but that wasn't really the contour that I wanted, so I just want to clear that one out. And we can go, well, we haven't used too many in the way of the directions. So through all makes it the same. We don't have a vertex. Up to surface isn't really going to do anything for us. Offset from surface will let me maintain the 5 millimeters. So if I pick the surface, it adds that face and then tells it to go an additional 5 millimeters. But I'm not seeing a preview, which tells me that it's going the wrong way. So if I reverse it, no, it went that way. Let's see, reverse the offset. Okay, there we go. So we got to click on those parameters if we're going to use those different in conditions and get the preview to show us that result. Okay, so that gives us our driver wheel. We'll make sure to hide the sketch to clean up. Control 7 will put us in isometric. And we'll add the name. All right, going to our next part. Let's get the drawing back in here. All right, the slider, yeah, it's at the very bottom of that. So I need to zoom up on it pretty good. It's still jumping around. All right, well. Let's see if I can adjust it off screen. No, it's still not going to cooperate. All right, so let's go with zoom in. See if I can go to the bottom of the page. All right, so 30 millimeters by 15 millimeters. And 5 millimeters deep, 5 millimeter depth, centered, full radius, 16 millimeters on the height. So fly that out of there. So our new part metric. And my favorite technique, I pretty much will do this one almost the same every time. If I want the right view, we'll open up the sketch. I'm going to pick out the rectangle, and the height can be 16, and then tab, and we'll go by 12 and hit enter. And to generate this radius, I can switch this from an object line to a construction line, and then that way I don't have to delete it. And then pretty much could use the tangent or the center point arc, or the 3-point for that matter, but we drag out to the edge, drag it through the sweep, connect the points, and then, oh, I did not get it attached to anything, so we're going to go to the midpoint so that we get that defined. Slipped into old habits and went to the S key, so S key is the same circle, circle, and this is 8 millimeters. All right, so this is gonna speed things up a little bit. If I start using the S key and the numeric input, we're gonna be able to follow that rhythm and go a little bit faster. So 30, and to use one of the other end conditions, let's go midplane. That'll keep the origin at the top center, and we can accept that. We'll go into the hole wizard. There is a hole wizard on the S key. So we'll let it get that started. This is another dowel pin hole. So on this one, 5 millimeters by 5 millimeters. So again, if we're thinking ahead to a ream, I really want to set this up to where I can make that geometry a little bit bigger, so, or a little bit deeper. So the 10 millimeter, and then we would need to modify the call out. So when we get to the drawing, we'll take a look at those. I'm going to go ahead and leave it at 10 millimeter, and we'll add a note to ream to 5 millimeter and have the extra to make sure that there's clearance for the geometry. So this then is our slider. The next part will be, see if I can get that to fly in here. And the next part will be the pin, and that's kind of the shaft. That one's the pin driver, and then the pin that goes, the slider pin. So this will be the like the driver shaft or the driver pin. So if we have to come up with naming. All right, need to get that out so I can see the dimensions. Okay, so another new, and this time I am leaving the parts open as I go. Typically, I would close these just to make sure that there is enough memory resources. So again, with anything that's a revolve, we're going to cut it in half again, and be looking at that quarter section. So line or center line, vertical infinite length, and that's just an easy way that I don't have to worry about running out of center line. And up and over, and that one is 10. And over and up, because it's in the diameter or with the center line, I don't think it's, well, that one came back, but I don't really need it. And then 10 millimeters on the height. All right, we can set the diameter. So first I'm going to apply the relations. Again, with the relation, well, I got the midpoint. That was probably my least favorite of the points for this. If I go to the points, those are going to be vertical. If I go to a line in the point, so like the line in the midpoint, those would be coincident. Midpoint wouldn't be a good choice there. But the easiest targets to acquire are the two object lines, making those collinear. All right, and then our diameters are going to be 10 and 14. And grab the midpoint again, so I'm just going to hit escape once, and that'll let me out. Apply the dimension. So place it, and then it's still in diametral, so 15. And this is one of those cases where I overrode the dimensions, so let's just go ahead and escape. All right, so D5 at sketch 1. Try not to overwrite those if I can help it. But if you do happen to overwrite one, it will typically revert back to the original. And we said that was 14. And I still want to make it 15. All right, 14 it is. All right, so L on the keyboard, or line from the command manager with revolve, is we want to close that off. Or if I don't close it off, then when we do the revolve, it's going to ask me, do you want it to be automatically closed? Which in this case, it's okay, but if there's a situation where it can cross over and violate the rules for the revolve, making a self-intersecting geometry, that'll cause it to fail. We're better off putting those that line in ourselves. So we'll save that. And we have the driver pin. Okay, next new part is going to be the bridge. And not sure what all I have open that's slowing my computer down, but we're having a little bit of a lag there. So front plane for this. Oh, let's fly that in there and take a look real quick. Okay, so we're just going to make the bridge. We have symmetry. We have the same 5mm geometries. The 5mm by 10mm depth on the holes, all pretty straightforward. A couple of radiuses, a couple of chamfers, some thoughts on the manufacturing center line, vertical infinite length. Place that, and then I'm looking to draw half of this, so L on the keyboard. And this is one of those places that I can use the continuous arc, and that'll put me into tangency. And should put me right back into line. Either that or I double clicked. So line. And I double clicked again, so well, I do want to be careful that, all right, so the center of the arc is picking up the coincident and the vertical. I don't really want that to be coincident, but as long as I'm aware of it, I'll be able to catch it by clicking on that line and saying, you know, it was nice that you put the coincident in there, but that doesn't really help me. And then I did not get a tangent here, so select Control Select, and we'll go tangent. We also could have just squared those off and made that a fillet in our geometry, either as a feature or as a sketch feature after we completed the sketch. So I didn't put the chamfers in there, so maybe we'll look at the chamfers that way. So all right, so we have 21 on the height. Overall, well, we're going to have to figure out what the location of that hole is. So 21 10 from the top. We're missing a dimension there, so that will make it interesting. Right click, sketch entities this time. Circle, we've got 8 millimeters for the shaft. That is 10 millimeters from the top, and so the dimension that we're missing is basically going to be the one for the 21. Okay, and then the radius, well, no, radius of 10. And then depends on where we want to have that slider line up with the shaft. So I'm going to put another 10 in there as a placeholder, since I don't know what that'll be as far as the best. So I'll put an inspection dimension. I can also right click and say mark this for the drawing, where everything is showing up in purple. Now that one will show up in black. All right, and then our overall is 60. So between the center line to the object line, opposite side of the center line, 60. And then our width is 14. So this is one of those cases where it got a little weird on the move, but I'm going to go ahead and apply it so we can put the 14 in there. And then I want to reverse the sense before I accept it. And this is one of the few places that you'll see a minus sign. Go ahead and accept it. When it applies it, it will still be a positive even though it threw it way out here. Okay, so I want to do the selection, and if I right click, one of the selection tools is to select the chain, which will find its way around. I'm going to hold down the control, pick the center line, mirror the entities. We have our geometry. Oh yeah, and I was going to put the chamfer in there. So the chamfer hides under, the sketch chamfer hides under the fillet. And those are 4 millimeters. We can do distance and distance. Probably we'll stay with the distance and angle since that's the way it's called out. Since these are connected, we can go to the corner and accept. And we have the geometry. And then the feature extrude. Oh yeah, I got out of it, so extrude. And we're going to have 10 millimeters on the thickness. We can stay with midplane. And then our geometry. Let's just go to the whole wizard. See if I could find it, but all right, so we're still on the dowel pins, 5 millimeters, 10 millimeters deep. The positions, it rotates up. I'm just going to go ahead and put those in. All right, so I could generate the center line and make these symmetrical, or in this case, I'm just going to go horizontal for those 3 points. So select, hold down the control button, select, hold down the control button, select, and those will go to all horizontal. And then because the 5 millimeters are from the edge, we'll go 5 millimeters there, and really drawing the center line as opposed to the and the symmetry as opposed to putting the 2 dimensions. It's about a wash. It's just if I need to change something on the center, I have to change the 2 dimensions in the future. All right, so this is now the bridge. And maybe I'll change that to slider bridge. Okay, our next part will be I'm going to say the crank arm or the connecting arm. So this has kind of that oblong shape, so I think we can use that. And the two circles, that'll be a pretty simple extrude. So we want the new part metric. And we're going to go into the sketch. Let's go ahead and do this one on the front plane, and we'll have uh, we'll be able to rotate it in the assembly as an example. So this is the center out to the side. So when we drag, let's see, 170 divided by 2 should be 85. And then the overall size, 5 millimeter radius, overall is 10. And apparently it doesn't like putting the dimensions after all of that onto the got ahead of myself there. Go S key. We'll place it. I want to make those equal. Okay, so 170, we can go to either of the lines, the two circles, the two arcs, pretty much pick. And the 170 is correct. So we'll accept that. We'll go with the radius of 5. And that's correct. That gives me fully defined sketch. And then the thickness when we go into the extrude will be 5 millimeters as well. So maybe I just keep this nice simple name like the drive arm. All right, let's find the drawings for the last two parts, the pin driver and last three parts. Well, the pin short, 5 millimeters by 16. Well, we can go ahead and knock those guys out. Okay, so top plane, sketch, S key, circle, 5 millimeter. I'm going to extend these out 16 millimeters. So it's got some clearance built in if we're 10 millimeters on each side and then 16 millimeters. That has 4 millimeters of adjustment. So another pin short, but there's not really a pin long, so I don't know about that one, but make sure I'm clicking on the save. Get the name in there. All right, the pin driver has the steps. This one would be good for the revolve as well. And I could modify the existing. So maybe we'll do the shaft, and then we'll take a look at revisiting the modify for the other pin. All right, so 170 by 8 for the shaft, and this one I'll put on the right, 8 millimeters. Let's go ahead into the extrude, 170. Don't know that I want that one on the midplane, so we'll switch it back to a blind in condition and save that. So we had the driver pin. Oh, that was the pin driver, so maybe that wasn't the best name. Well, this one's going to be the driver shaft then. All right, so hopefully I don't mess that up too bad on the drawing, since I've gone away and they didn't quite provide best naming. So that'll be a good reason to rename. All right, so let's go find that that driver pin. All right, so I don't mess this up, first thing I want to do is a save as. And we're going to save as, copy, and open. All right, so this is going to be the new well, we got the same. How about we just do drive pin? I'll figure out the naming here in a bit. All right, so the advantage here is I am in the driver pin. It will probably ask me here in a second if I want to keep the other part open. Okay, so keep the original document open. And when we double click on the sketch, if I don't want to go into the sketch, I can just double click and start editing. Or I can edit the sketch, and the advantage with editing the sketch is we can see the results pretty much real time, not wait until we do the rebuild to figure out which dimension or what happened. So let's go 5 millimeters, 5 millimeters, 10 millimeters is good. And then the diameters, we can still be 10, but this is one of those places that I added the collinear. Now I've got to get it out of there. So the outside then is we're going to have one at 10 and one at 8 and one at 5. So 5. And then 8. And I need to add the 8 back in, or add the 8 in. And then this one goes to 10. And when I accept it, that looks pretty good. And we'll take a quick look at the drawing, make sure we've done all of the parts. Let's expand that out. So intentionally blank. So yeah, I think that's pretty much all of our components, and we'll pick up next with the assembly.